Hi everyone, and welcome to lesson 9-7. We're going to talk about reflections in space, which pretty much means we're going to talk about reflections of 3D objects. Just a little heads up, this lesson's a little bit of a longer one. There's a lot of definitions, so just get prepared. Be prepared. First, we're going to talk about the perpendicular bisector. A perpendicular bisector is when a plane is a perpendicular bisector of a segment if the plane is perpendicular to the segment and the midpoint is on the plane. So if we want to construct a picture for this, we'll have our plane here, and we'll call the plane M, where we'll have our segment going through our plane M with a midpoint on plane M. We'll call this point A, we'll call our midpoint B, and we'll call our end point of our segment C. To finish up this construction, we'll have to prove that it's a 90 degree, that the segment is 90 degree is perpendicular to the plane, which means that it's at 90 degrees. And then we also have to say that it's a bisector, meaning that B is the midpoint, so AB is the same distance as BC. So when we reflect images of a point over a plane, we can either have the points not on the plane or the point on the plane. So if we think back to our picture from before, we have our plane here, and I believe I called it plane M. We have our segment with point A, a midpoint B, and the end point C. And this is perpendicular with AB the same distance as BC. So a point not on the plane would be point A. When point A is reflected over plane M, which is called the reflecting plane, point A now becomes point C. A point on the plane would be point B. When point B is reflected over plane M, point B becomes the same point it was. So point B will be point B when reflected on the plane. So our points not on the plane would be point A and point C. Points on the plane is point B, and our reflecting plane or plane of reflection is plane M. Congruent figures is when two shapes are congruent if the shapes are the same after the reflection. So if we have our reflecting plane between these two shapes, my plane's going to be very small, then we should be seeing that the shape on the left is the same as the shape on the right, meaning this point is the same as this point, and this point is the same as this one once reflecting through the plane. So this should be to this one. The segments drawn here then would be perpendicular bisectors of the plane. So this is perpendicular, this one, and then their midpoints of each one, roughly drawn, will be on the plane and making these distances equal. Therefore, the two shapes are congruent. The symmetry plane is a plane that divides the shape into congruent figures on both sides of the plane. So if you look at the picture of the lobster on the left here, we have that blue plane. that blue plane here that shows that this half of the lobster is going to be the exact same, or is going to be a congruent figure to this back side of the lobster. Now you could try and draw a plane. You can draw a plane going this way through the lobster, but it won't make it a symmetry plane because the front half of the lobster wouldn't be the same as the back half. Now if we look at our milk bottle, we have the symmetry plane right here that shows this half is the same as the other half. There are more than one symmetry plane for the milk bottle. If you wanted to, you could also draw it this way, going through the milk bottle. So this would be cutting across the top here. Another way would be if you went from a corner to a corner. So if we have our plane going like this, we're going to have a plane going across like that. So there's multiple planes that can, symmetry planes for the milk bottle. This side is going to be the same as the other side. Now we're going to do an example of finding the number of symmetry planes for the hexagonal prism. One of the first ones we can look at is the plane that would cut the prism in half this way. So that would give us 1. For these, I won't draw the planes just so I can reduce the number of lines and keep it a little bit simpler. Another symmetry plane will be one that cuts the prism in half this way from one side to the opposite. So it's going to cut down this way. That creates 1. We can also do that for these two, all the opposite 2's. So there's 2 there, and then this one going this way. So we have 3 there. Then we'll have a couple more going from this vertice down, and this one over, and then this one. So we'll have 3. Each of these planes is like if we were taking the hexagonal prism and we were cutting it in half. So if we would take those 2 halves, they would be equal. So the total number of symmetry planes for the hexagonal prism would equal 7. That would be 1 parallel to the ground, and then 6 perpendicular to the ground. So that's the lesson for today. Be ready for homework in class tomorrow and bring any questions you have.